Don't forget to subscribe and press the bell icon to never miss a video from testbook.com.
Hello friends, so welcome to our series of concept through questions. So our purpose is to revise the concepts, and while going through these videos every day, so I assume, so whenever I start these videos, so I assume that you have already gone through the topic, and our only purpose is to revise the topic via question. So if anyone is doing a topic for the very first time, please don't hesitate and please don't have any kind of fear. If you do not know how to solve that question, you can definitely ask me the concept at the last of the class. So in the last class, I think one or two students joined who were not aware of liquids in relative equilibrium. So I had shared two links of the previous videos which I had put on YouTube earlier. So you can go through the links and you can definitely ask me if there is any kind of doubt. So today we are starting with fluid kinematics, and before I start there is an information. So some notifications have come out. I think in IRCON some notifications have come out. So they have come out in IRCON, NPCIL and BARC. So for BTech people, for diploma people, so there are a few vacancies. Just have a look. If you are eligible for the vacancy, you can definitely try for it. Okay. So please do have a look at these websites. Please do look the websites of these organizations. You might find a possible vacancy over there. So these vacancies were released in 2-3 days only. Okay. So what is the topic for today? So today we are starting the topic of fluid kinematics. So today we will revise velocity, acceleration and discharge. So anyone who is watching the video, they can ask doubts anytime. They can ask questions anytime. So guys, I hope you remember whenever I do fluid mechanics, so in the beginning of the subject only, we discuss an example of designing an aeroplane or designing a submarine. And sometimes if time allows, I show the wind tunnel experiment also. And then I say, ki bhaiya, velocity is the most important property in fluid mechanics. Once you know the velocity, you can predict a lot of things. You can find out acceleration. You can put the acceleration in Euler's equation. You can predict the pressure field. If the fluid is viscous in nature, then from velocity, you can predict the viscous stress also. From velocity, you can find out how the fluid is deforming as the fluid moves ahead. From velocity, you can find out the density field also using continuity equation. From velocity, you can suggest whether the flow is steady, unsteady, uniform, non-uniform, rotational, irrotational, etc. So I always say that velocity is the most important property. And when we are doing mechanics, when we are solving motion, to solve motion, there are two mathematical methods, mathematical approaches. One of them is Lagrangian approach and the other one is Eulerian approach. So in our fluid mechanics, we follow Eulerian approach. And every term is expressed as a function of position and time, whether velocity, acceleration, density, temperature, pressure, anything is there, we express it as a function of position and time. That is Eulerian approach. So let us see some 2-3 basic questions. So we will discuss about velocity today. We are going to discuss about velocity today. We will discuss about acceleration today and discharge today. So today I will not talk about local and convective acceleration. This question we will do on Thursday. So tomorrow and day after tomorrow, there won't be any revision session. So we will have the next revision session on Thursday. And in 3-4 sessions, you can say, we will start with fluid dynamics also. Okay, now there is a particular question on the slide, and actually this question I copied from Som Sahab's book. So SK Som, chapter number 3, solved example, I think number 4. So what the question says, for a fluid particle, the motion of the fluid particle is expressed by these two functions, where x and y are the position coordinates of the particle at time instant t. Okay, what it says कि there is a fluid particle, so obviously the fluid particle is moving and the position of the fluid particle is expressed as x coordinate and y coordinate. Now for this motion, for this particular fluid particle, first of all they are asking you what is the path line of the particle. What are they asking you? Path line of the particle. And secondly, they are asking you what is the velocity field of the flow. So there are two things: path line of individual fluid particle, path line of individual fluid particle, and the second is velocity field. Second one is velocity field. So in GATE exam, if such kind of questions come, so it most probably they can ask you the question in this manner. So if they ask you a single option question, they will give some 4 options. In 4 options there will be different equations. They will ask you which of these equations corresponds to path line of the fluid particle. Similarly, there will be 4 options. Which one of these options correspond to velocity field of the flow? Velocity field of the flow, not of particle, of the flow. And if it is an MSQ question, then out of 4 options, 2 options will be related to path line, only one will be correct. 2 options will be related to velocity field, only one will be correct. So this is the possibility of question. So first of all, before solving the question, let us try to revise. Let us quickly revise, not thoroughly, quickly. Let us quickly revise the Lagrangian versus Eulerian approach. So guys, I hope you remember every time, and in fact in every class, I think in every class since 2018, I have used this common example. So there are some other examples also, but this example is a very simple one and easy to explain. So I generally use this example. I think hardly at 1 or 2 places I have taken a different example. Maybe once in Coimbatore or once in Mysore. Otherwise, every center, every online class I have taken the same example. What was the example? There is a very big city like Bangalore or Delhi. In such big cities, the number of vehicles is like 80 lakh. And actually this data I got from newspaper. So, and the number of crossings, road crossings, Choraha. So number of crossings in the city is 10,000. I want to analyze which crossing is heavy traffic, medium traffic and light traffic. So I want to do the traffic analysis of the city. So we always learn that in the age of computers and electronics, there are 2 possibilities. So one possibility is either at every crossing there is a sensor. Now what this sensor will do? So let us say this is crossing number 1, Mall Road. So every city has a Mall Road, right? So I am very fond of food videos. So I watch a lot of food videos on YouTube, and in every food video they show that there is a Mall Road and some food carts will be there. So there is a Mall Road crossing. Okay. So what this sensor is going to count? This sensor will count. This sensor will create a data, and that data will be number of cars according to the time. So how many number of cars are passing through Mall Road from 6 to 7 a.m. Similarly, how many number of cars are crossing from Mall Road from 7 to 8 a.m. and 8 to 9 a.m., 9 to 10 p.m. So there are 24 hours. So 24 values will be there. Hai na? Now suppose from 6 to 7 a.m. the number of cars passing through the crossing is only 50. So this is very light traffic. So let us switch off the lights. There will not be any policeman. But from 7 to 8 a.m. this becomes 100. Then 8 to 9 a.m. this becomes 500. Medium traffic. Let us switch on the lights. From 9 to 10 a.m. this becomes 1000. Heavy traffic. So we will need a policeman also, right? So from this data, we are able to analyze one crossing. So for every crossing, there will be a data, and in the data, there will be 24 values. So one data gives analysis of one crossing for the entire day. So such kind of analysis where you are studying a crossing, where you are studying a point, and for the point you are collecting some data. What is that data? Number of cars versus time, property variation with time. So when you study property variation with time at a point, that is called as Eulerian approach. Now that property can be pressure, that property can be temperature, density, velocity, number of particles crossing the point, anything. Okay. So in Eulerian approach, we study the variation of properties at a point with time. Say for example, here the property is number of cars passing through the crossing in 1 hour. And time goes from 6 to 7 a.m., 7 to 8 a.m., 8 to 9 a.m. and so on. So this was our Lagrangian approach. I hope you remember this. This was what? Lagrangian approach, right? Sorry. This was Eulerian approach. है ना? So in Eulerian approach, we study locations. Then there is the other approach. So I always crack this joke that you guys are not Ajay Devgan, hai na? So Ajay Devgan can drive 2 cars with one leg in one car and other leg in other car, hai na? But we are normal people. So every driver is sitting in one car. So I always say, now we will ask the drivers to collect the data. So there are 80 lakh vehicles. So there are 80 lakh drivers. Now these drivers, say for example driver A. Now what this driver will do? This driver will make a note. He will write some data in his diary. So he will mark what is his position, what is the position of his vehicle with respect to time. So in the morning, the vehicle was in the home because the driver was getting ready to go to the office. From 7 to 8 a.m. also, the vehicle was at home because the driver was having breakfast and watching news. And from 8 to 9 a.m., the vehicle was on bypass because the driver was going to office. Then from 9 to 5 p.m., the vehicle was in office. So we have position versus time data of one vehicle, of one particle. So like this, there are 80 lakh vehicles. So there are 80 lakh particles. Now we will study this data, position versus time. So we will study the position versus time data of all the particles together. So we will study 80 lakh data together. We will study 80 lakh data together. So we will read each data and we will count the number of cars that are passing through Mall Road from 6 to 7 a.m. Okay. So we will study 80 lakh data and we will count the number of cars that are passing through Mall Road from 6 to 7 a.m. So bhaiya, car number A, it is at home, so do not count it. Car number B, it is at home, do not count it. Car number C, it is at Mall Road, so that is the first count. Okay, so I hope you remember this. So we will count the number of cars which are passing through Mall Road from 6 to 7 a.m. But please note, once I read 80 lakh data, I got the analysis of Mall Road for only 1 hour. There are 24 hours in a day. So I will repeat this activity 24 times. So 80 lakh data will be read 24 times. You will get analysis of 1 day. But this will give you the analysis of only one crossing, not the entire city. So for entire city, you will repeat the activities again. How many crossings are there? 10,000. So this is the number of iterations required to complete the analysis of city. Whereas in this case, one data gives the complete analysis of a location. So 10,000 data gives the complete analysis of the city. Here 80 lakh data which will be read 24 times and then 10,000 times, you will get the complete analysis of city. Definitely this is an extremely lengthy, complicated and expensive approach which is not possible by the current computing technology. So such kind of approach where you start with the position of particle versus time, that is called as Lagrangian approach. What is this called as? Lagrangian approach. So in Lagrangian approach, we start with this position of particle as a function of time. Position of particle as a function of time. And then we study these functions for every particle together and we try to find out the information required by us. So this is Lagrangian approach. Lagrangian approach is suitable only when the number of particles in the system is less. Say for example, billiards game. So number of particles is I think only 10 or 12, right? अब मैं number भूल गया हूँ, पहले खेला करते थे, but जो number of balls होगा वो बहुत कम होगा, है ना? So Lagrangian approach is suitable for designing a billiards game, but it is not suitable for understanding the flow of fluid because number of particles is large. अब जनरली क्लास में क्या होता है? सो इन द क्लास आई गिव यू एग्जांपल्स वेयर लैग्रेंजियन अप्रोच आर यूजफुल, बट इन योर केस यू विल फॉलो ओनली यूलेरियन अप्रोच, है ना? नाउ चेक. सो इन द क्वेश्चन व्हाट इज गिवन टू अस? इन द क्वेश्चन पोजीशन ऑफ पार्टिकल एज अ फंक्शन ऑफ टाइम इज गिवन टू अस. So definitely this is Lagrangian representation of the flow. Position of fluid particle as a function of time is given to us. So this is Lagrangian approach, है ना? This is what? Lagrangian approach. This is not Eulerian approach. This is Lagrangian approach. And when we talk of velocity field is a term of Eulerian approach. Field means when you express something as a function of position and time. ठीक है ना? ठीक है? So actually Lagrangian approach is given to you in the question and they are asking you Eulerian approach of the flow. So I hope this is clear to you, right? So we will solve the question one by one. So firstly, let us focus on the path line of the fluid particle. Okay. So if I consider the path line of fluid particle, well, first of all, what do you mean by path line of fluid particle? Is this a concept of Eulerian approach or is this a concept of Lagrangian approach? So obviously you guys will tell me that sir, when we consider path line means path traced by a fluid particle as it moves ahead. So here we are not talking of a single location. Here we are talking of a fluid particle. So fluid particle was initially located at x0, y0. Fluid particle was later on located at x1, y1, x2, y2. है ना? So what we want to find out? We want to find out how the position of the particle will change as a function of time. है ना? Now check. So this path traced by the particle, that is called as path line. Now at some particular time instant t, this is the position of particle x, y. And this point will obviously lie on the path line. Now what is the equation of line? So I always tell, say for example, this is a line. So when you say y is equal to mx plus c, what does this mean? So this means if we take a point whose coordinates are x, y, then the coordinates are together going to satisfy this equation. है ना? So when you write the equation of a line, that means the point which lies on the line, its coordinates will satisfy that equation. तो जब भी आप एक लाइन की इक्वेशन लिखते हैं, उसका मतलब यही होता है कि भैया अगर लाइन पे एक पॉइंट ले लेंगे तो उस पॉइंट के जो कोऑर्डिनेट्स हैं x और y, वो उस इक्वेशन को सेटिस्फाई करेंगे. So equation of a line is a relationship between x and y of a point on the line. ठीक है? Now check your function. Check your function. So what I have at a particular time instant, I have the x coordinate of the particle. At a particular time instant, I have the y coordinate of the particle. I want to find out a relationship between x and y. है ना? I want to find out a relationship between x and y. that will become the path line of the particle. So let us do it. So firstly, let me do one thing. Let me copy this set of equation again on another slide. Let me copy this set of equation again on another slide. Okay. So this is the question. Now guys, check. So when we want to relate x and y, obviously we can do one thing. I think e raised to power kt, this is like common, है ना, in our equation. E raised to power kt is like common in our equation. So I think from the second equation, I can say e raised to power kt, this is equal to y by y naught. Or we can also say e raised to power minus kt, that is equal to y naught by y. I have taken a negative power. Or e raised to power minus 2 kt, I think that will become y naught square by y square. है ना? So second equation tells you e raised to power minus kt and e raised to power minus 2 kt. Obviously now you are able to see why I am doing this. Because e raised to power minus kt in the first equation, this can be written as y naught by y. E raised to power minus 2 kt in the second equation, this can be written as y naught square by y square. So I can write x is equal to x naught into y naught by y plus y naught into 1 minus y naught square by y square. Now check for yourself. Check for yourself. What do you have? You have a relationship between x and y of the point. है ना? उस पॉइंट के x और y कोऑर्डिनेट के बीच का रिलेशनशिप मिल गया. सो डेफिनेटली दिस इज द पाथ लाइन ऑफ द फ्लूइड पार्टिकल. दिस इज द इक्वेशन ऑफ पाथ लाइन ऑफ द फ्लूइड पार्टिकल. ओके. So all of the students who will watch the video later on, so I can see actually only one student is watching along with me. ठीक है? So if there is any kind of doubt, please do let me know. So definitely these kinds of questions I have already discussed in the classes, but still अगर आपको कोई भी doubt लगे तो आप लोग मुझे कभी भी पूछ सकते हैं. ठीक है ना? So let's move on to the second part now. Let us move on to the second part now. Now for the same kind of flow, so basically it says there is some fluid flowing and the particles are moving in this manner. So for a single particle we can write this equation, and this is equation in Lagrangian form, position of particle as a function of time. Now they are asking you what is the velocity field. So obviously velocity field means any velocity component will be expressed as function of position and time. Any velocity component will be expressed as function of position and time. So what is the meaning of this? The meaning of this is that if we take the flow field and explain the flow field by Cartesian coordinate system, then at a particular point, let the coordinates will be x, y, z. This is a point. Now the fluid is flowing. So what will happen? A particle will come to the point and move ahead. Next particle will come to the point and move ahead. So particles are continuously passing through the point. So at some time instant t, there will be a particle which will be crossing the point. So for that particle, what are the velocity components? So we always say like this: velocity at point x, y, z when the time is t. But always remember, this is not the velocity of the point. Even though we are expressing it for a point, this is the velocity of a particle. ठीक है? So अभी तो नहीं, अभी गेट एग्जाम बहुत नियर है, मगर और मैंने एक्चुअली मेरे एक दो स्टूडेंट्स को मैंने प्रॉमिस किया हुआ है कि मैं उन्हें कुछ एक्स्ट्रा वीडियोस बना के दूंगा फॉर एक्सी, लाइक नेवियर स्टोक्स इक्वेशन, रेनॉल्ड्स ट्रांसपोर्ट थ्योरम एंड ऑल. सो वंस गेट एग्जाम गेट्स ओवर, आई विल ब्रिंग अ कोर्स of maybe 8 to 10 hours, and in that course we will dig a little deeper in Lagrangian mechanics and Eulerian mechanics. So I will tell you something about flow field, about field theory. तो field theory में सिर्फ velocity नहीं, electric field, magnetic field सारी चीजें आ जाती हैं. तो हम देखेंगे, अगर मतलब गेट एग्जाम जब ओवर हो जाएगा ना, तो उसके थोड़े टाइम बाद मैं आपको ये चीजें बताऊंगा फील्ड थ्योरी के बारे में. तब हम थोड़ा यूलेरियन अप्रोच, लैग्रेंजियन अप्रोच को ज्यादा फॉर्मुलेट करेंगे. और अगर आपने वो कोर्स कर लिया 9-10 घंटे का, तो आपको लोकल चेंजेस, कन्वेक्टिव चेंजेस, मटेरियल डेरिवेटिव्स, ये सारी चीजें बहुत अच्छे से समझ आ जाएंगी. तो अभी तो नहीं, गेट एग्जाम के बाद देखेंगे, ठीक है. सो वी वांट दिस एक्सप्रेशन. व्हाट डू वी वांट? We want this expression. We want velocity components at a point when the time is t. Now the question is how to find this out. It's very easy. Say for example, first of all, the equations which are given to us, they are corresponding to a fluid particle. Okay. Now just have a look what I am going to do. Actually the things are very simple. Actually it's very simple. Actually it is very simple, and let me do one thing. Let me zoom this out. So by the way, आज ना मेरा मैथ्स का क्लास था, तो मैंने मैथ्स के क्लास में यही दिखाया था कि मैट्रिक्स के एप्लीकेशंस दिखाए थे. जूम इन, जूम आउट, इमेज प्रोसेसिंग, पैंडेमिक का फ्यूचर प्रेडिक्ट करना. तो मैट्रिक्स के एप्लीकेशन देख रहे थे और जूम इन, जूम आउट कर रहे थे. ओके, नाउ चेक. What is this? Position coordinate of particle at a time instant t. So if I derivate the position with respect to time, I will get the velocity of the particle at the same time instant. है ना? This is the position of particle when the time is t, and this is the velocity of particle when the time is t. Let us derivate this first. So once you will derivate it, you will have minus k x naught e raised to power minus kt. So e raised to power minus kt. So minus k will come down. And similarly, here I will have y naught 1 minus e raised to power minus 2 kt. So I think y naught is some sort of constant, and derivative of 1 is 0. Derivative of e raised to power minus 2 kt, that will become e raised to power minus this will become 2y naught e raised to power minus 2 kt. First of all, you can ask me, sir, how come you are saying x naught and y naught are constants? You know what? Actually x naught, y naught is the initial position of particle. What I did when I was solving the question, in my mind I thought if the time instant is 0, what will be the initial position? It was x naught. Time instant is 0, what was the initial position? Y naught. So x naught, y naught represent the initial position of particles. So they are like constants. So what I have u is equal to minus k x naught e raised to power minus kt plus 2y naught e raised to power minus 2 kt. Now guys, just think for yourself. X is the position of particle at time instant t. Velocity is the position of particle. U is the velocity of particle at time instant t. So x for t, u for t. I think I can relate u and x. Then it will become velocity of the particle when the particle is at x. Velocity of particle when the particle is at x. So velocity at point x. Eulerian approach. समझ रहे हैं आप? तो इस तरीके से सिंपल इंग्लिश में ही, बाय यूजिंग सिंपल इंग्लिश, यू कैन कन्वर्ट इंग्लिश और हिंदी, है ना. जैसे मतलब हिंदी की तो स्टेटमेंट्स हैं, ये हिंदी इंग्लिश की स्टेटमेंट्स हैं. ये मैथ्स कहाँ था, फिजिक्स कहाँ था? ये तो हमने सिंपल इतना बोला कि भैया पार्टिकल की वेलोसिटी जब टाइम टी है, पार्टिकल की पोजीशन जब टाइम टी है, तो पोजीशन और वेलोसिटी को रिलेट किया जा सकता है. तो हमें पता लग जाएगा पार्टिकल की वेलोसिटी जब पोजीशन इतनी है, यानी कि उस पोजीशन की वेलोसिटी, सो यूलेरियन अप्रोच आ जाएगा. सो हमें यही काम करना है. सो वी हैव टू रिलेट u with x. नाउ चेक फॉर योरसेल्फ हाउ आई एम गोइंग टू डू इट. सो एक्चुअली आई विल एलिमिनेट टाइम फ्रॉम here. So let me write this function here. U is equal to minus kx naught e raised to power minus kt plus obviously I have missed a k over here. Guys, please check. I have missed a k over here. Plus 2k y naught e raised to power minus 2kt. Now what I will do, I will try to eliminate this time term and bring a x over here. So I will get velocity as a function of position, and actually it's very easy to do. Say for example, in x there is x naught e raised to power minus kt. So x naught e raised to power minus kt, and there is e raised to power minus 2kt also. That is common, na? Hai na? So let me do one thing. First of all, let me take minus k as common. So if I will take minus k as common, I will have x naught e raised to power minus kt plus, sorry, not plus, minus now, minus 2y naught e raised to power minus 2kt. This is what I am going to get. Now just do one thing. I think I can write this as minus k x naught e raised to power minus kt minus y naught e raised to power minus 2kt minus y naught e raised to power minus 2kt. So that minus 2 I have split as minus 1 and minus 1. And then I can also do plus y naught minus y naught. I hope this is correct only, hai na? Nothing is going to change if you add and subtract y naught. Now consider this term and this term together. I think what will happen, so by the way, इस तरह की जो modifications हैं, मतलब हम तो इंजीनियर्स है ना, हमारा मैथमेटिक्स इतना स्ट्रांग नहीं है. तो आप बोलोगे सर आपको कैसे पता लगा? मैंने इस टाइप के मल्टीपल क्वेश्चंस प्रैक्टिस कर रखे हैं, तो थोड़ा सा इक्वेशन को देख के मुझे पता लग जाता है. मगर आप थोड़ा सा ध्यान से देखोगे ना, इक्वेशन पे थोड़ा सा टाइम लगाओगे, तो आप डेफिनेटली इस तरह की मॉडिफिकेशंस कर पाओगे. और गेट एग्जाम में बहुत कॉम्प्लिकेटेड क्वेश्चन नहीं आने वाला है. गेट एग्जाम में जो मैथमेटिकल फंक्शन होगा वो इससे सिंपल ही होने वाला है, या एट मैक्स इस लेवल का होने वाला है, इससे ज्यादा लेवल का नहीं होगा. नाउ चेक व्हाट यू विल हैव. यू विल हैव u which is equal to minus k into x naught e raised to power minus kt, and then we combined these two terms na, we combined these two terms, and I think y naught is a common over here. So what you will do, you will write plus y naught 1 minus e raised to power minus kt. Then there is a minus y naught e raised to power, sorry, minus 2kt e raised to power minus 2kt, and you have a minus y naught also, right? Now obviously this one is x. Obviously this one is x. So what you will do, you will write u is equal to minus kx, है ना? And check this one. Actually this one is very easy. This one is very easy. You know how? I told you earlier na, what is e raised to power minus 2kt? That is y naught square by y square. What is that? Y naught square by y square. So this will become minus y naught into y naught square by y square minus y naught, है ना? So what you are getting? You are getting u is equal to minus kx minus y naught cube by y square minus y naught. Now check for yourself. Velocity at a position xy. Velocity at a position xy. So velocity as a function of position. So definitely this is the Eulerian function now. So from Lagrangian approach, we moved on to Eulerian approach, right? Now let us consider the v component of velocity also. So in the similar manner, we will solve the v component of velocity. So for the particle y is equal to y naught e raised to power kt. Y is equal to y naught e raised to power kt. So if I will write the y component of velocity of particle, that will be dy by dt. So this will become ky naught e raised to power kt. But y naught e raised to power kt, that is nothing but y. So you have ky. So velocity at point y. So we have x component of velocity as minus x minus y naught cube by y square minus y naught, and v component of velocity as ky. So velocity at point x comma y. So this is your Eulerian field. Now please note, whenever you say steady, unsteady, uniform, non-uniform, 1D, 2D, 3D, rotational, irrotational, these explanations are based on Eulerian approach. Just by looking at the Lagrangian function, never say that the flow is steady or unsteady. This steadiness, unsteadiness is defined for Eulerian approach only. I hope you remember this. In my classes I have discussed this, especially in the latest full courses. So when we will look at Eulerian approach, you will observe velocity is not a function of time. So this is a steady state flow. This is a steady state flow. पता है क्या प्रॉब्लम आती? प्रॉब्लम ये आती कि बच्चा ना Lagrangian approach देखता, बच्चा बोलता velocity is a function of time. Have a look yourself. Velocity is a function of time. But भैया, this is written in Lagrangian approach. This is written in what? Lagrangian approach. So suppose in actual the flow is convective. What do you mean by convective flow? When a particle goes from one point to the other point, due to converging diverging passage, there will be a change in velocity. So velocity here will be 1 meter per second. Velocity here will be 2 meter per second because the passage is converging. Now this explanation is in Eulerian approach. So when the particle is here, it is 1 meter per second. When the particle goes from here to here, it is 2 meter per second. So for the particle, the velocity will definitely change with the time. है ना? But we are not talking of steadiness. We are talking of uniformity. I am talking of convective acceleration. So आपको ये चीज ध्यान रखनी है कि steadiness, uniformity, local acceleration, convective acceleration, these are terms of Eulerian approach, not for Lagrangian approach. And from Eulerian approach, we observe that this is a steady state flow. This kind of question was asked in GATE 2019 also. Very simple question. बहुत ही simple question था. ठीक है? So all those students who have joined just now, so guys, the same thing, every day we are discussing one question from one concept. So yesterday we discussed liquids in relative equilibrium. So I had a question where the container was filled with water and it was moving on an inclined plane. So my question was, what can be the maximum possible value of acceleration so that the water does not spill out of the container? So yesterday we discussed this question. So today we are discussing a question on Lagrangian and Eulerian approach. So मैंने बताया था कि गेट में कैसा क्वेश्चन पूछा जा सकता है और इसको MSQ कैसे बनाया जा सकता है. ठीक है? Now in MSQ this option can also be there, whether the flow is steady, unsteady, uniform, non-uniform. So definitely you will say in Eulerian approach. So Lagrangian approach was given to us. We came to Eulerian approach and we observed that velocity is not a function of time, so steady state flow, but velocity components are function of position, so non-uniform flow. ठीक है? So I hope this is clear to you. Now let us have a look at one more question also. One simple question, and let me frame it. Actually this question is not there in the book or somewhere. I am just framing it randomly. So what it says कि भैया there is a velocity field. So actually from the next question in Som Sahab's kitab, I am picking up an example. So velocity field is given. I am asking you something else. I am asking you discharge from the velocity field. They are asking you acceleration. I am asking you the discharge. Okay, what I am asking you? Discharge. Now what it says, that a flow field is defined by a velocity vector 4 plus xy plus 2 time I cap, 4 plus xy plus 2 time I cap plus 6x cube j cap plus 3xt square plus z k cap. Okay, so a flow field is given like this. Now my question to you is, let me get back to your screen. So my question to you is that in the flow field, if I consider a section given by x equal to 1 plane, which plane? X equal to 1 plane. So I think when I am talking of x equal to 1 plane, I am talking of this plane. I am talking of this plane, right? I am talking of this plane. So, and obviously this point will be x equal to 1, right? So x equal to 1 plane means a plane parallel to yz plane but passing through x equal to 1. So every point on this plane, its x coordinate will be 1. Whatever may be the y coordinate, whatever may be the z coordinate, but x coordinate is 1. Now on this plane, I have a rectangular section given like this, and maybe the height of this rectangle is 2 units and the width of this rectangle is 3 units. So predict the discharge from the section. Predict the discharge from the section. So this is the next point. This is the next question. Okay? So what is the question? I think a 3D unsteady spatial. Why spatial? Because 3 velocity components. Why unsteady? Because time is also given. And why 3D? Because the velocity components depend upon x, y, z. So this velocity field is given to you, and for a particular section they are asking you the discharge. And since velocity is a function of time, the discharge will change with the time. So I am asking you, what is the discharge through this rectangle at a time instant t equal to 2 seconds. At a time instant t equal to 2 seconds. Okay. So before going through the question, let us quickly revise the question. So what we have is, there is some sort of converging passage. The same question, the same example I am choosing, which I have done in classes also. So guys, generally we write discharge is equal to velocity into area of cross section. But have a look. So this is a cross section. At the cross section, if I take a point, at this point the particle will have a velocity maybe in this direction. So once you resolve the velocity will have some components u and v. Consider the component u, which is perpendicular to the section, and v is parallel to the section. So I always say, if you will move parallel to the door, you will never cross the door. You will never go out of the room. If you move perpendicular to the door, then only you cross the room, then only you move out. So when we are talking of discharge, we need the perpendicular velocity components. So discharge is not based on actual velocity, it is based on perpendicular velocity components. Now this point on the cross section, it has an area dA. And even if I consider only u, I hope everyone remembers that there is a effect of viscosity which is called as boundary layer formation. So on the cross section, the points which are away from the surface, velocity component will be high, and the points which are near the surface, the velocity component will be low. So we will get a velocity profile like this. So what we will do, we will take a point whose area is dA. At the point the velocity is u. So for the point, the discharge is going to be uda. This is the discharge for one point. So when you add the discharge for all the points, you will get total discharge. This is how we find out total discharge. So let us use the same concept for our question also. Now this plane we are talking about, this is parallel to YZ plane. So when we are talking of perpendicular velocity component, that is the x component of velocity, u component of velocity. So definitely if I take a point on the section, there will be u, there will be v, there will be w. But to calculate the discharge, we will only take what? We will take x component of velocity. Similarly, if a section like this was given to you, you will take only y component of velocity. And if a section like this is given to you, you will take only w. Okay, na? But in this particular question, we will take u. So let me draw the figure again. So what I have, this is the x direction, this is the y direction, and this is the z direction, right? And this is the cross section. This is your cross section, which is a rectangle. The cross section has units 3 and 2. And x component of velocity, how much was the x component of velocity? 4 plus xy plus 2t. 4 plus xy plus 2t. Now the plane that we are talking about, its x coordinate is 1. So all the points on this plane, their x coordinate is 1 only. And we are calculating the discharge for time instant equal to 2. So this will become 2 into 2, that is 4. So velocity at any point will be 4 plus y. So for this particular time instant only, if the time will change, the velocity value will also change. So for this particular time instant, the velocity at any point on the section is given as 8 plus y. 8 plus y. And obviously what is y? Y is the distance of the point from bottom. Y is the distance of the point from bottom. Now what you will do? You will find out the discharge. Discharge is integral of u dA. So discharge will become integral of 8 plus y dA. Discharge will become integral of 8 plus y dA. And we have to consider all the points that lie on this area. So what will happen? You just open the bracket. So 8 dA integral over the entire area plus integral of y dA over the entire area. Now 8 is a constant. So total discharge will be 8 into integral of dA plus integral of y dA. Now area into distance from the bottom edge, that is like first moment of area. So this is nothing but first moment of area, first moment of this area about the bottom edge, How do you write first moment of area? So first moment of area is nothing, total area multiplied by distance of centroid from the edge. Now this entire height is 2. So what is the distance of centroid from bottom? 1. What is the total area? 2 by 3, that is 6. So what will be the first moment of area? Area into distance of centroid, that is 6. Now what you will have? This will become discharge, which will be 8 into total area plus total area into distance of centroid from the bottom. So this will become 8 into 2 into 3 plus 2 into 3 into 1. And I think your answer will be 8 into 6, that is 48. 48 plus 6, that is 54. So 54 units, that is going to be the discharge, right? So you have calculated discharge also. Now once we calculate the discharge, we can find out the mean flow velocity. So discharge upon area, total area, that is 54 by 2 into 3, which is 6, and you will get 9 units. So mean flow velocity for the flow, for the section, for the rectangular section, when the time is 2 seconds, is this much. So we have found out the mean flow velocity also. So hi Ronak, how are you? Nice to see you here. So Ronak, beta, every day so actually I have already done the course with my students, with my current students, जो लोग मेरे साथ पढ़ रहे थे अभी. So अभी क्या कर रहे हैं कि मैं उन लोगों के लिए रिवीजन वीडियोस बना रहा हूँ. So उनको जैसे टाइम लगता है वो ये वीडियोस देख लेते हैं. So मैं डेली चैप्टर वाइज एक वीडियो बनाता हूँ 1 घंटे का, जिसमें एक टॉपिक से रिलेटेड कोई क्वेश्चन डिस्कस करता हूँ. And today I am discussing velocity, I mean Eulerian and Lagrangian approach. So velocity, acceleration and discharge, which are like the fundamental terms in fluid kinematics and dynamics. So velocity we have discussed. So in Lagrangian approach, a function for a fluid particle was given. We found out the path line of the fluid particle. Then we converted the Lagrangian approach into Eulerian approach and we found out the velocity field. Now a velocity field was given to us. So velocity field was something like this. ठीक है, इस तरह से एक velocity field था मेरे पास. ऐसा कहाँ गया velocity field, कहाँ गया, ये यहाँ रहा. So ये ऊपर हमें एक velocity field दिया हुआ है. And this velocity field, for this velocity field, I said, let me consider that there is a rectangle like this, imaginary rectangle. So for this rectangle, how much will be the discharge? So I am calculating that discharge. ठीक है ना? So 54 units was the discharge, and if I divide 54 by the total area, I will get mean flow velocity. ठीक है? So I think that's all for today. एक छोटा सा concept देख लेते हैं फटाफट, but we will revise that concept in the next session only, that is acceleration. So I hope you remember when we are talking of velocity in Eulerian approach, so every term will be written as function of position and time. Now the derivative of velocity with respect to time, that is the acceleration. And once you derivate it, this will become u del u by del x plus v del u by del y plus w del u by del z plus del u by del time. Similarly, if we talk of acceleration along y, this will become u del v by del x plus v del v by del y plus w del v by del z plus del v by del time. And like this, we can write down for z also. Now, in every acceleration, the first 3 terms together, they represent the derivative of velocity field with respect to space coordinate. So we always call this as convective acceleration along x direction. So convective acceleration along x direction, this means if we consider 2 points along the x direction, the geometry at this point and the geometry at this point, they are different. Maybe the passage is converging passage or maybe the passage is diverging passage. So when we compare 2 different locations, at the 2 locations velocity can never be same. So this is convective difference of velocity. So when the fluid particle will go from inlet to outlet, it will definitely experience a velocity change because of change in geometry. That is called as convective acceleration. But when you talk of local acceleration, you focus on one point. At this point, the pressure, density, temperature, any condition is changing with time. See, because of the change in property at the point, there will be a change in velocity at the point. So in the morning, the velocity at turbine inlet was only 10 meters per second. But in the evening, velocity at turbine inlet is 50 meters per second. So at the same location, the velocity is changing with the time due to change in local pressure. So that is called as local acceleration. ठीक है ना? So I hope आपको याद होगा. So हम क्या करते हैं जब हमें velocity function दिए होते हैं, so we find out these derivatives and we substitute the derivatives over here. We get the acceleration functions. Now they will tell you the points where you want to find out the acceleration. We will substitute the point coordinates in our functions and we will get the acceleration at a point when the time is this. ठीक है ना? बाकी acceleration को next video में revise करेंगे. So now on Tuesday and Wednesday, so these 2 days, tomorrow and day after tomorrow, I might not come online. Okay, and the next video on local and convective acceleration that will come out on Thursday. So Thursday, Friday, Saturday, Sunday, Monday, Tuesday, we will have videos continuous, kinematics and dynamics. Then Wednesday, no video. Then we will move on to boundary layer theorem, dimensional analysis and so on. ठीक है, इस तरीके से चलो ठीक है. सो एनीवन हु वॉचेस द वीडियो एनी टाइम प्लीज डू लेट मी नो. आप लोगों के पास मेरा फोन नंबर होता ही है, कोई भी डाउट होगा पूछ लेना, घबराना नहीं है. आप अपने टीचर से भी डाउट पूछ सकते हैं, जहां से भी पढ़ रहे हैं ना, सेल्फ स्टडी कर रहे हैं अपने फ्रेंड से पूछो, पर यह कि अपना क्वेश्चंस को रिवाइज करो और एक्स्ट्रा मत पढ़ो. बहुत सारे स्टूडेंट्स पूछते हैं कि सर मैंने सरफेस टेंशन नहीं पढ़ा, पढ़ लूं क्या? मैंने लिक्विड इन रिलेटिव इक्विलिब्रियम नहीं पढ़ा, वो पढ़ लूं क्या पहले? तो मेरा एक ही जवाब होता है, पहले ये बताओ रिवाइज कितना किया है. गेट क्वेश्चन बैंक को दोबारा सॉल्व करके देखा है कि नहीं? दोबारा सॉल्व करना है, एक बार नहीं दोबारा सॉल्व करना है, तभी स्पीड बढ़ेगी, एक्यूरेसी बढ़ेगी. तो पहले रिवाइज करो, एक बार रिवीजन मल्टीपल टाइम्स हो जाएगी, फिर बच्चों ये टॉपिक्स को छेड़ना. बट बिलीव मी, आपने सिलेबस 100% कर लिया, एक बार रिवाइज नहीं किया, मार्क्स नहीं आएंगे. 80% सिलेबस किया मगर बार बार रिवाइज किया, यू विल गेट मोर देन 70 मार्क्स. आई नेवर रेड मैन्युफैक्चरिंग. मुझे मैन्युफैक्चरिंग का कुछ भी नहीं आता था, एक नंबर का भी मैन्युफैक्चरिंग नहीं आता था मुझे कभी भी, क्योंकि मैं कभी पढ़ता ही नहीं था. इंडस्ट्रियल इंजीनियरिंग मैंने कभी नहीं पढ़ा था, समझ रहे हैं? और एप्टीट्यूड का इंग्लिश तो पूछो ही नहीं. तो बच्चे कितना 20 मार्क्स तो यहीं चले गए, समझ रहे हैं आप? मैन्युफैक्चरिंग में कोई 2-3 क्वेश्चन लगा भी लेता हूँ, बट फिर भी 75 मार्क्स लेके आ पाते थे. क्यों लेके आ पाते थे? क्योंकि बाकी सब्जेक्ट्स रिवाइज बहुत कर रखे थे. आप समझ रहे हैं? सो रिवीजन इज इंपॉर्टेंट, रिवीजन इज इंपॉर्टेंट. ठीक है, अब ये मत पूछना है सर मैन्युफैक्चरिंग क्यों नहीं पढ़ते थे, उसके कुछ और रीजन हैं. ठीक है, तो हम कभी डिस्कस करेंगे. ठीक है, चलो फिर थैंक यू एंड सी यू इन द नेक्स्ट वीडियो. आई होप दिस वीडियो वॉज यूजफुल फॉर यू. सो हमने क्या किया, लैग्रेंजियन अप्रोच को यूलेरियन अप्रोच में कन्वर्ट किया, थोड़ा सा मैथमेटिकल काम था, और देखा कि कैसे डिस्चार्ज को प्रेडिक्ट करते हैं. ठीक है, थैंक यू, सी यू इन द नेक्स्ट क्लास.